Hi, how many concurrent connections can your server handle? Welcome to this channel. My name is Edson. I'm a software engineer who makes video to help educate other engineers. I've always been wondering how many concurrent connections a server can handle based on the size of the server. So in this video, what I will do, I will get a virtual machine from Google, load that virtual machine with WordPress as a program, which is a content management system. About 40% of the internet use WordPress. And then I will use another tool called JMeter to generate load and then use the reporting from JMeter so that we can analyze how the size of the server is impacted by the load. So if this is something you're interested, you're in the right place. Let's run the experiment. Okay, the next step is to create a virtual machine. For that, I will be using the gcloud command. I'll use this. The reason I went that path is so that I can repeat this experiment over and over, and so that you also guys can see the code and make suggestions. In it, you can see I call the VM demo WordPress. So the most important thing is the machine type, which is the E2 medium. According to Google, the E2 medium has a capacity of 2 virtual CPU and 4 GB of memory. And as you can see from Google, usually people use this machine type for low traffic web server, back office app, containerized microservices, small database, virtual desktop, and development and test environment. Since this is mostly testing the limit of things, so this size fit the small experiment. Start creating the virtual machine. First, we create a directory and then we put the content of the code inside this file, and then we execute the gcloud command by running this from the command line. Now you can see we have created a virtual machine. In the output, we can see the IP address, the machine size, and the location where the machine was created. Now that we created the virtual machine, we can take a look into the console to see the machine. So like you can see here, we have the machine called demo WordPress. We can have the external IP and the internal IP. Let's SSH into the machine so we can start installing WordPress inside of it. For this, I will authorize, and then once I SSH, then I can easily start to install WordPress. I've written a script to help with the installation. Honestly, I didn't write everything myself from scratch. I went into the official Ubuntu website, and from there, I was able to find all of the steps that is needed. The Ubuntu website has all of the code. So for me, all I have to do was to put them together and massage the code a little bit to fit the execution in one way. So I don't have to stop and type. For example, some part you have to physically type your password. So I found a way to make it easier where I can just go ahead and execute the code. If you want to read more about it, go on that page. I'm going to put it in the description of this video so that you can go and read this even more. Okay, now we're going to execute the script so that we can have WordPress installed in the virtual machine. Okay, the installation is successfully completed. Let's test the server. Because I did not get install SSL certificate, this will not work because if you try to reach the server on port 443, which is usually the port for SSL, but now I'm gonna go over HTTP because again, no SSL on port 80. So as you can see, WordPress has been successfully installed. Usually when you have a fresh install of WordPress, they ask you to fill some form, give some simple information. Okay, let's test what the website looks like. So after WordPress is installed, and if we're not logged in, we can easily go on the main website. Okay, this is what the website looks like. It's a simple template that WordPress comes with that you can use. Since I'm just doing a simple demo, I'm not going to create a more robust website or make any change on it. I'm just gonna use the current website as is. Okay, if you're not familiar with JMeter, let me give you a quick overview. So in this JMeter, I use a template to set HTTP requests. So the templates, you can find them here, when you click on this button, then you will find template, and then the template you can see simple HTTP requests. This would help create this one. And then I remove something called a listener so that I can not use the UI. So thread group, that's where you set up how many requests you want to send. And this is the variable for it. What I'm going to do in this one, I will keep incrementing this variable starting from 10 requests up to 2000 requests. I will do 10, then after that 100, and after that 500, after that 1000, and then after that 2000. The ramp-up period is the time to get all these requests sent. So for example, if I have to send 10 users in 10 seconds, so every 1 second one user would send a request. Like if I have to send 100 requests in 10 seconds, so I can estimate that 10 requests per second. If I get like 1,000 requests in 10 seconds, it's probably mean I have about 100 user concurrent requests per second. So this variable, I'll keep increasing it, and then create the load test, then send the request, and then record the data. And then with that data, then after that, we'll analyze the data and talk a little bit about it. All right, let's start with sending the request and then look at the result. Okay, as you can see, I created different folder for each test that I'm gonna be executing so that I can create the report. And then also I create those extra files so that if in the future I want to load the result into JMeter, I can just load these to analyze it inside JMeter. However, we'll be using a web interface to look at the result. Okay, before we go ahead and execute the command, let's quickly go about how I run JMeter. So this is the command I executed. JMeter, that's the binary, -n mean non GUI, so that the reason that I didn't put the GUI is so that we can use as much of the computer resources, because we don't need the GUI, so we do it from the command line. -t load test, -t specify the GMX test plain file, which is called loadtest.gmx. That contains the configuration for the load test, including the thread, the request, and test parameters. -l WordPress.gtl. This is define the result log file. It's the raw data from the test one that we will store in this file. This is typically contain things like response time, thread count, and request status. And finally, -e, that's meant to generate a report. That's the HTML report we talk about. And then -o is the output. And then this is the folder that the output will be at. So for example, when I modify my load test.gmx to do 10 requests per 10 seconds, so I'll put it in that folder. For 100 requests every 10 seconds, I'll put the response in this folder and keep going until we get to 2000 requests. Okay, this is the first report. This report, we sent 10 requests in 10 seconds, probably like 1 request per second. And all of the requests passed. As you can see, let's take a look at the response time and latency. As you can see, it takes an average of 197 milliseconds. The fastest out of those 10 took 180 milliseconds, and the request that took the longest took 230 milliseconds. So we had the median, that's about 190. That means the median mean half of the requests took less, or at least half of the requests took less than 194 milliseconds, and maybe the other half takes slightly more. So those are the data for 10 requests. As you can see, it doesn't take that long, about 180 milliseconds. So this second table is, you see, we sent 50 requests, and out of those 50 requests, we can have an idea of the latency. We take an average of 180 is 190 millisecond, and the fastest one was executed in 179 millisecond, and the request that took longest took about 119 seconds. We didn't have any error. All of the requests went. So this is about 5 requests per second, and there is nothing special. The server can handle this without issue. So now when we increase the amount of requests from 50 requests over 10 seconds, which is about 5 requests per second, we increase it to like 10 requests per second, we still have a healthy state. We can see we have like 189, 87 millisecond, and the one that took the longest went to 260. So nothing special. So at this rate, we can see a server can probably handle 10 concurrent requests per second without having any choking. To get interesting, as we increase to about 20 requests per second, which is about 200 requests over 10 seconds, you can see now it took an average of 2 seconds for each request to be fulfilled. The fastest request took about 200 millisecond, 300 millisecond, which is not bad, but still you can see there is some slowness. And the request that took the longest took about 3 seconds, close to 4 seconds. So the median was correct. And as you can see, the moment we start hitting 20 requests per second, that's when the server start to increase the latency for every subsequent request. Okay, now we're gonna take a look at what happened when we start sending 50 concurrent requests per second, which is an average about 500 requests over 10 seconds. Now the servers really start to choking. The request that took the least amount of time to be executed was about 680 milliseconds, and the request that took the longest took about 21 seconds to get back a reply. As you can see, it doesn't go linearly as we keep going, and so far waiting for a site to load for 21 seconds, it's a lot, and by that time most people would click away. So we can start to see the server start to degrade as we start to have like 50 consequent requests per second. Now we start seeing a different thing. The server can no longer serve every request that it gets. As we increase the amount of user from 1 to 100 user per second, now we can start to see at least 2% of the requests failed. The average time a user have to wait now goes to 28 seconds. A good 28 seconds. Most people would click away by that time. So the request that took the fastest to response took about 390 milliseconds, which is good. And the one that took the longest to get back their reply took 50 seconds. 50 seconds. Like you can see, this is a lot. Half of the people had to wait at least 30 seconds before they can get their reply. And at this level, we can see that the client timeout, because the client, I put a 30-second timeout, so the client just timeout. Like here are the error that we see. So non-status code, we get exception, the connection got timeout. Again, connection timeout. Connection timeout can happen from the client side. I didn't investigate if it happened from the client side or the server side, but pretty much 23% of our requests fail. We can see response over time, how this is changing. So as we increase the load, it takes very much more time to serve these new incoming requests. The response percentile over time, I don't want to talk too much about this one, but I want to talk about is the throughput. The throughput is how many bytes is being sent per second. So as you have more user, there is a degradation on the throughput. Probably my guess is because as you have more requests coming in, the operating system is working harder to manage the queue and at the same time to actually process the request. So this extra work needed to both manage the queue of requests and then managing all of these incoming requests make it so that as you get more user, your server is not as performant. It cannot reply very fast over time. And this is the latency. The latency is how long you have to wait to get your first byte. When you have less user, it's very fast. But as you increase the amount of user, the latest user that came has to wait way longer compared to the earlier request. When we start having 200 requests per second, at that point, close to half of the requests fail. Because the latency is so high, the client just gets disconnected. We can see here we have about 600 milliseconds. That's the fastest one, probably the first request. But as we increase the amount of requests per second, most people have to wait an average of 21 seconds, and maximum person has to wait about a minute. And as you can see, more requests per second, the client connection timeout. So the client was opening the socket and then didn't get a reply on time and it just timeout. So most of the response timeout. And also if we look at the chart over time, you can see the response time increase. So it takes longer for the latest request to get served. And similar to earlier, the latency, we can see the latency, the throughput get exponentially more. The latency over time get exponentially more, where at least you have to wait a good 17, 18, 20 seconds for your request to be served. Okay, now we're gonna take a look at the hardware to see how change in the volume of requests is impacting the hardware on that virtual machine. Here is the CPU utilization graph. As you can see, we can look at the spike. So the first spike that happened at this time, which was 946, correlate with when I sent 5 requests per second. So I'm not sure why it's as high. I wasn't expecting it. And the second spike that happened at around 902 correlate at 200 requests. That was about 20 requests per second. And then the third was about, I think 50 requests per second. And the last two, one was about 1,000 requests where we have like 100 requests per second. And then finally we had that last spike where I sent 2,000 requests with a throughput of about 200 requests per second. As you can see, the CPU utilization is above 100% for some of those requests. Usually Google would let you use the CPU utilization above 100% during a spike, but they're not gonna let you use it continuously. And you can see there is an impact on the CPU as the amount of requests is going up. Hence why you have such a high latency, because the CPU is so busy that there is not enough core for the, for the other process to wait. So now let's look at the networking graph. So the first spike has nothing to do with me, but the second spike is the amount of requests, byte that the server sent to the client. And as you can see, it's also as there are more requests coming in, the server has to generate more byte. Usually when we send an HTTP request, it's just small text. However, the reply can be a lot of text, including HTML, CSS, and JavaScript. So that's why you have such a large amount. Thank you very much for watching this video. This kind of give you some insight into why Netflix had some issue during the Mike Tyson versus Jake Paul live stream they were doing. So as you can see, the more people are trying to hit your system, the longer it takes for the system to respond back to them. Hence you would get that circling thing if you're on Netflix and watching it. But that's a simplification of the problem. I hope this is you gain some value on it. The next video I will try to optimize the server by leveraging cache, and we run the same experiment and see if there is a difference and then compare the difference. All right, thanks. Ciao.